Alrighty, how we doing? We're in a brand new chapter. It's a brand new day. Well, probably night, because usually you're watching these at... Anyway, here we go. Chapter 9.1 of BJU Geometry 4th edition. We're looking at analyzing three-dimensional figures. After 8.7, which probably felt like just a horrible thing, this is going to be much easier. Ready? Ready to relax? Here we go. We're going to be talking about solids in this chapter. So do me a solid and pay attention. I'm full of it today. Anyway, when you look at a solid, a polyhedra, or a prism, and these are all words that you'll become more familiar with later on. When you look at a solid object, if we talk about a lateral edge, that's a line formed where two faces come together. Two faces come together. Sounds like a dance in middle school. A base edge is a line formed where a face meets a base. Let me show you some pictures. It'll be a lot easier there. Okay, here we go, pictures. This is a sphere. A sphere has no edges. Enough said. This is a prism, and we'll define these a little bit more carefully as we go forward, but a prism has two bases, two repeated shapes. This triangle is just like this triangle. And then it's joined by a set of rectangles that take a line from the triangle and turn it into a three-dimensional object by lining up with another triangle, right? This rectangle is a face. This triangle is a base. This line formed where this face meets this face is a lateral edge. This line, formed where a face meets a base, is a baseline or a base edge. Okay, this is a cone, can also be a pyramid. Okay, this is a cone, and we don't have any lateral edges on a round pyramid or on a cone because there's no hard edges of the faces. But we do have base edges where the circle meets the surface of the cone. Okay, this is a pentagonal pyramid. Here we have lateral edges again. This is a face, this triangle is a face, this triangle is a face, the triangle back there is a face. All of these are faces, right? And all these lines where faces meet are lateral edges. These are base edges, where the base, the thing in this case that it sits on, but a base is actually the shape of polygon that defines the rest of the solid. The line where the base meets a face, this would be a base edge. Okay, so bases, faces, lateral edges, and face edges, or base edges, we've talked about in this little brief moment. If you need any help with that, go back. Alrighty, this is something that's new in this edition of BJU's geometry book. I don't remember having taught this ever before, and it's kind of cool. So if we're looking at a polyhedron, a three-dimensional shape, all the sides of which are some kind of polygon, if we are talking about that, and we are wondering how many faces, how many vertices, and how many edges are there, there's this neat little formula. And I don't know how to say this guy's last name. Euler, I don't know, have fun with that. Euler's formula is that the number of vertices minus the number of edges plus the number of faces is always 2. Oh, that's kind of cool. One more time, the number of vertices, the number of points on the polyhedron, okay, minus the number of edges, how many lines there are on the polyhedron, plus the number of faces, all those polygons that make up the surfaces there, equals 2. Cool, cool beans. So you can use this if you're given a polygon or a polyhedron with a certain number of faces. You can figure out how many edges if you know how many vertices, or you can figure out how many vertices if you know how many edges or faces, or back and forth. You can flip this all around, and it'll be a good time. Okay, let's move on. Next, we have this definition of something called a cross-section. A cross-section is a intersection with a plane passing through a figure. So you've got a solid of some kind, and now you're going to slice the solid, and then you're going to look at the solid and see, what is that shape? Okay, so if you take a sphere and you whack it with a knife and you like cut an apple, right? Cut an orange, and you look at it, what do you have? You've got a circle. Oh, cool. If you take a square pyramid and you whack it this way and you look at it, what do you have? Got a triangle. Take a square pyramid, cut it this way, look at it, what do you have? Got a square. Oh, these are all cross sections, right? These are all shapes that you make when you whack a surface with a knife. Okay, let's look at several examples. This example asks you to sketch a cross section of a solid bounded by a circular cone. Here I have a circular cone, and this plane slices through the circular cone. And I'm going to ask you, what's the shape where the plane meets the cone? What's that shape? And that's going to take you cutting that in your brain and looking at it and thinking, what is that? That's a circle, right? You take a circular cone, you cross section it this way, and you get a circle. Okay, what happens if you do it at an angle? Do you still get a circle? Think about it for a moment. Pause the video if you want to scratch your head. No, you don't get a circle anymore. Now you get an ellipsis. Kind of cool, right? You get kind of this oval thing because it's not a straight circle, it's a slanty plane. And so the slanty plane creates an oval. That's kind of neat. What happens if you go like this? Oh, no, your brain is hurting. Okay, I got a straight line because the bottom of this thing is flat. But then this part is going to be a big curve. So I've got a curve and a straight line. It's going to be something like that. That's cool. It's a parabola that's limited by a straight line. That's kind of cool. Alrighty. What about this one? That should be easier. Slice it vertically and take a look at it in your brain. What's that? That is a triangle. Okay. Alrighty. This should not be too bad. Last idea, and that is the idea of a net. Now, the terminology here I think is unfortunate, because when I think of a net, I think of something with holes in it that has a bunch of lines. I don't at all think of all of the surface areas of a solid. But that's what this is. A net is a two-dimensional pattern that can be folded to form a three-dimensional surface, defining a solid. So if you have a brick of something, let's say it's a brick of cheese, and I want to get the net of that brick of cheese, I've got to think about all of the things that I would fold out and where I would cut it and lay it flat. And what I've got is all of the surfaces laid flat next to each other. But it's called a net. Sorry about the word. It's not my word. It's all of the surfaces of a solid laid out flat. Okay, let me show you some pictures. This is a prism, triangular prism. Okay, if you were to take all of those surfaces and lay it out flat, what would it look like? Well, I would have two triangles, right? So let's say that I take my X-Acto knife and I cut and I cut, and I do the same thing here, and I cut and I cut, and I lay that triangle flat and I lay this triangle flat. Now I've got two triangles with a rectangle between them, and then it's got a little teepee. Got to get rid of the teepee. It's got to be flat. So I'm going to take my knife and I'm going to cut along here. And now I'm going to take that and I'm going to lay it open. Now what do I have? Can you do this in your brain? Because this is all spatial reasoning. And for some of you, it's going to be a piece of cake. For some of you, this is going to, make you wet your pants. You lay all this flat, and I've got three rectangles and two triangles. And now the tricky thing is, how are they arranged? It depends on how you cut it. There's more than one proper way to draw a net, but there's lots of improper ways to draw a net. However you draw it, you've got to be able to fold it to make the prism. So I would probably have three long rectangles that share their long edges, and then triangles on the center rectangle. That's, I think, the simplest way to draw it. You could draw it all kinds of different ways. You could take one of those triangles and make it the center and have a rectangle coming out of each side, and on the end of one of these rectangles another triangle. That's also correct, but it's funky. Maybe you're funky. Here's how I would draw it. I would have these three rectangles, and then a triangle on each one. You've got to label your dimensions, 24 inches, 6, 6, 6, 6, 6. And so that is a net. Okay. Now, we we'll be doing this a bunch in class, either looking at a net and answering the question, what's the solid, or looking at a solid and trying to draw a net. Okay, so those are things that you'll do. You'll also use this to do some area. So identify the three-dimensional figure formed by the net and find the total area of its faces. This looks like a cereal box, unfolded. Can you see that in your brain? You wrap all this together in your brain and be like, oh yeah, it's a box of Cheerios. I have here a rectangular prism. Because if I folded these four things up and then folded this across the top, I'd have a rectangular prism. Okay, what's the total area? Well, nets actually make it really easy to find total area. So I have a very large rectangle here and then two smaller ones. This big rectangle is 8 centimeters by 2 and another 2, that's 4. And 6 here is 10 and 6 more is 16. 8 times 16 will give me the area of this large rectangle. And then these small rectangles are 6 by 2, or 12. And I've got 2 of those, so 24. 24 plus this will give me the whole thing, right? This is the solid. It's a rectangular prism. And then here's my formula. I've got, oh, they made it a lot more complicated. They said I have 2 rectangles that are 8 by 2. That's these guys. I have 2 rectangles that are 6 by 2. That's these guys. And I have 2 rectangles that are 6 by 8. I think it's a lot easier to just look at as big a pieces at a time as you can. But however you do it, the answer is 152 square centimeters. Okay, that's about as hard as it gets for this, so hopefully your brain is still working. Okay, let me know if you have any questions in the comments field below, and I'll get to them as quick as I can. Otherwise, we'll talk about it tomorrow in class. Until then, Jesus loves you, and so do I. God bless you. Have a good night.